going to be talking about y equals mx plus c. Now this is just a way of writing some equations, what we call linear equations. So if we have a linear equation, we can write it in the form y equals mx plus c. And it turns out that this is a really nice, useful form for things to be written in. So in this video, I'm just going to be expanding on what we mean by this form and how we can exploit the form once we've got it. So on the screen are three different equations. Well, no, actually, as it turns out, all three of these are exactly the same equation. They're just the same equation written in different ways. I can see that by just seeing how I would get from one to the other. So if I started with this top one and I took away 2x from both sides, I would end up with the second one. And if I started with the second one and then factorized it, I would end up with this bottom equation. So all three of these are actually the same equation. They are giving exactly the same information. They're just written in a different form. Now the one that we're going to be interested in today is this middle equation here, because this middle equation is the one that is written in the form y equals mx plus c. I can see that because it is y equals something lots of x plus something. So when we're talking about the y equals mx plus c, the y and the x are what we call variables, because they're the things that are on our axes. So we need them to stay. We need to have a y and an x for this to make sense. So the y and the x are just going to stay as they are. The m and the c, however, are what we call constants. So they are just numbers. So in this case, the number m is -2 and the number c is 4. So if I have y equals some number times x plus some number, then I have an equation of the form y equals mx plus c. Now, of course, m and c can be all sorts of different things. What I'm going to show you now is some examples of equations that are in the form y equals mx plus c, and then some equations that are not in the form y equals mx plus c. So we start off with y equals 5x plus 6. And this is one that looks fairly obviously the same as that top one. Instead of m, we've got a 5. Instead of c, we've got a 6. For this next one, y equals 5x. Some people are thrown off by that because it doesn't seem to have a c. But of course we know that what I've secretly got here is I've got 5x plus 0, because adding 0 doesn't change anything. So this actually is in the form y equals mx plus c. It's just that c is 0. So we don't need to be scared by things that are missing a c, because we know that if it's missing a c, it's just the 0. Now the same logic sort of holds if m is 0, but not quite, so we're not really going to be talking about that case. Okay, another one here. M can be negative. It was on the last slide. There's nothing stopping that. So this is still in the form y equals mx plus c. This is still in that form because we've just got -5 as m. However, this one is more likely to throw people off, I think, because in this one we've got y equals 5x take away 6. And people think, well, that take away isn't a plus, so this doesn't work. But of course we know that take away is just a fancy way of saying add negative. So I often say subtraction is a myth we tell primary school children. It's not really a separate thing. It's just addition in disguise. So what we mean by this is we mean 5x plus -6. So in this example, we do have a c. That c is -6. So this is still in the form y equals mx plus c. Okay, next one. Now here I want to show you that the numbers can be complicated. There's no reason they can't be. And my go-to complicated number is a square root, a surd. So y equals the square root of 5, lots of x, plus 6 is absolutely fine. Because m is the square root of 5, and c is 6. Similarly, if we've got y equals 5x plus root 6, then m is 5 and c is root 6, so that's absolutely fine. And as one final example of being slightly complicated, we can have fractions here as well. So this is just m equals 5 over 2 and c equals 6. The important thing is, as long as m and c are numbers, it doesn't matter how complicated those numbers are, they're still numbers, so we're absolutely fine. Right, now we're going to look at some things that are not in the form y equals mx plus c. So firstly, we've got 2y equals 5x plus 6. Now this is not in the right form because we've got 2y here instead. It wouldn't take long to get this into the right form if I just divided both sides by 2, but at the minute it's not, and we need to recognize that it's not in the right form. Here we've got y plus 5x equals 6, and so the 5x is on the wrong side of the equation. It can't be on the same side as y. Again, it would not take long to get this into the right form. It isn't in the right form right now. Here we've got a root x instead of an x. Now we were fine square rooting the 5 because that's still just a number, but root x is not the same as just x, so this is not in the right form. This is not okay. Well, sorry, it is okay, it's fine, it's still an equation, it's just not in the form that we want it to be in. It's not in the form y equals mx plus c. For similar reasons, we can't square the x, because that would take us into a different form. This is what we call a quadratic equation. It is not in the right form. Oh, now this one's interesting. Y equals 6 plus 5x, because this one is painfully close to being in the right form. It is so near. All we have to do is we have to move these the other way around, make it into 5x plus 6, and then it would be y equals mx plus c. So again, there's nothing wrong with this. This is absolutely fine to write down. It's just not in the form y equals mx plus c. Next one, we've got y plus 5x minus 6 equals 0. This turns out to be a very common, very useful way of writing equations, but it's not the form y equals mx plus c. And then finally, we've got one where we've squared the y as well. Now this is a kind of equation you won't see until A level, but it is definitely not in the form y equals mx plus c, because the y's been squared. So why do I care so much about y equals mx plus c? Why is this the one we're fussing about? Well, it turns out that when equations happen to be in this form, we can do some quite useful things with that m and that c. And so that's what I'm going to be looking at now. Before I do that, a quick reminder from a previous video about y-intercepts. So the y-intercept of an equation, of a line, is where it crosses the y-axis. And we discovered that if we have the equation, we can find the y-intercept by substituting x equals 0 into the equation. So what happens if we do that with y equals mx plus c? What happens if we substitute in 0? That is how we would find our y-intercept. So for the purposes of this, I'm just leaving m and c as they are because I want them to represent whatever numbers would be in that case. So I'm doing a bit of standard algebra. Let's consider x equals 0. Let's just put in x equals 0 into the equation. So instead of that x, I put in a 0. Y equals m times 0 plus c. Well, m times 0. Anything times 0 is 0, which means that m times 0 must be 0. So we must have y equals c. What that tells us is that the y-intercept of this graph is just c. So nothing complicated, it's just c. So if I have an equation of the form y equals mx plus c, the y-intercept is just c. Now that is a lovely starting point. That's nice, but we can actually go further with this by considering another concept we've already seen, the gradient. Now the gradient of a straight line is the amount y increases by when x increases by 1. So what I'm going to do here is I'm going to take y equals mx plus c and I'm going to increase x by 1. Well, what is x increased by 1? It's x plus 1. So instead of x, I'm going to consider what happens with x plus 1, in which case we would have y equals m lots of x plus 1. Can you see how I've just put x plus 1 instead of x? I put the brackets in there because I know I've got an addition in the middle, so I had to put brackets in. But now that I've got brackets, I might as well expand them. So I'm going to do m times x plus m times m. Expand the brackets. And then I'm just going to rearrange this order so that it looks like the thing I want it to look like, which is this. So what this is actually showing us is that if I increase x by 1, I'm increasing y by m. So if I increase x by 1, I increase y by m. Well, that was our definition of the gradient. It's the amount y increases by as x increases by 1. So m is the gradient of this graph. Now that is really nice. That really simplifies things for us. Because if I have something in the form y equals mx plus c, without doing any extra work, without thinking about any other maths, I can tell you straight away the gradient of my line is whatever that m is, and the y-intercept of that line is whatever that c is. I can do that straight away, super quick. So if I have y equals 2x plus 5, I can tell you without any extra thinking the gradient of this line is 2, and the y-intercept of this line is 5. Boom, easy. If I have y equals 2x minus 5, I can tell you with no extra thinking the gradient of this line is 2, and the y-intercept of this line is minus 5. If I have the equation y equals negative 2x plus 5, I can tell you without any extra thinking the gradient of this line is negative 2, and the y-intercept of this line is 5. So you can see that this is a very powerful form, and that's why we talk about the form y equals mx plus c, is because if we happen to have an equation in that correct form, we don't have to do any extra work to get the important information out. Okay, the key points from this video. We can write the same equation in several different forms. So all of the equations I showed you before were fine. They were all just equations, but only some of them were of the form y equals mx plus c. When our equation happens to be in the form y equals mx plus c, then m is the gradient and c is the y-intercept. So we don't have to do any extra work to find those quantities.